Hey, Clark. This is the first summer homework packet review. So, problem number 1 says list all factors of each number. And in the example, we list the factors 1, 2, 3, 4, 6, and 12 for the number 12. So you can pause this video and copy these down if you need to, but I highly recommend that you do these on your own. This is a wonderful practice in just your multiplication tables and practicing factoring numbers. You'll notice that I had to come out to the side here a little bit for 60 and 80. Whoops. But please use this to check your work and don't use it to copy. I think that would be a waste of your time. Down here, then, we could find the greatest common factor between two numbers. So for 12 and 18, if we go back up, we see that both 12 and 18 have a 6 in them, and that would be the largest number in the factors of 12s that is also in the factors of 18. So we use the greatest common factor to do such things as dividing fractions, or simplifying fractions, sorry. So 12/18ths, here you can see the 12 and the 18, and now the 12 is a numerator, the 18 is the denominator, to divide by the greatest common factor and come up with an equivalent simplified fraction. And then we can also use the greatest common factor to pull that froggy back out of the pond. So when we actually factor polynomials, we are dividing out the GCF. You'll also see that this greatest common factor of 12x squared and 18x includes an x as well. So another idea of factoring x squared and x and then figuring out the largest number of x's you can divide out of both terms. Okay, to move on, there was a greatest common factor of 30 and 50, using the GCF to simplify a fraction, and then dividing out the greatest common factor to create the factored form of this polynomial. Number 4, greatest common factor of 32 and 40 is 16, simplifying to get 2/5, and then factoring 32x squared plus 40x. And finally, on the front of page 1, greatest common factor of 28 and 42 is 14, using it to simplify 28 42 into 2/3, and finally to factor out 28x squared plus 42x. Okay, on the back of page 1, nothing. I guess this is the back of page 1. This is all of the multiples. This took me a little while to do, and you once again can pause the video to check your work, but I would recommend you don't copy. It's once again good to go through your multiplication tables and good mental math exercises. In the second group of problems, we're looking for the least common multiple. This is the smallest number that appears in both multiple groups. So once again, for 8 and 12, we are looking for a multiple of 8 that is also a multiple of 12. 24 is the smallest number that both 8 and 12 multiply to become. We use the least common multiple to make common denominators when we're adding fractions, and we call that the least common denominator. And then we can add fractions with unlike bases by making them like bases and then adding the numerators. Least common multiple of 10 and 12 is 60. That allows us to add 3/10 plus 5/12 to get 43/60. The LCM of 12 and 16 is 48. Converting fractions, we get 29/48. And the LCM of 15 and 20 is 60. Once again, converting to a common denominator and adding to get 17/60. Down here, we are factoring quadratic trinomials. So this is the FOIL in reverse problem. Basically, when we are doing these, we are asking ourselves, what two numbers multiply to be 12 and add to be 7? We have to think about reversing the FOIL process. So as I began, say this one that's prime, I would say, oh, this is a quadratic trinomial. So if I'm going to factor that, it's going to have to look like some sort of binomial times binomial, or as we commonly call it, a FOIL problem. Then I'm looking for everything that factors to be 18. 1 times 18, 2 times 9, 3 times 6. Of those groups, I'm looking for a pair to add to be 10. Nope, nope, and nope. And here you can see that once I got all my factors of 18 being nopes for 10, then I realized nothing will work, and that's a prime polynomial. However, 2 and 9 multiply to be 18, add to be 11. 4 and 5 multiply to be 20, add to be 9. Negative 6 and positive 2 multiply to be negative 12, add to be negative 4. 5 and negative 3 multiply to be negative 15, add to be 2. Negative 10 and negative 2 multiply to be positive 20, add to be negative 12. And negative 4 and positive 4 multiply to be negative 16, add to be 0. This is actually called a difference of two squares. We'll be looking at this in Algebra 2. X squared minus 16. A lot of times when students see it looking like this without that plus 0x, they forget that they can consider it to be a quadratic trinomial, so they forget how to factor it. Okay, that's everything for page 1, front and back. See ya!